Welcome to another episode of Daily AI Brief, where we dive into the latest advancements shaping the world of artificial intelligence. Today, we're exploring ByteDance's innovative audio generation model, a new minimal hardware AI, Mira Murati's push for customizable AI models, and the latest in model distillation techniques. Ready to decode these breakthroughs? Let's get started. ByteDance has unleashed a game changer in the realm of audio production with their latest model, Seed Audio 1.0. Imagine being able to generate entire audio scenes from a single text prompt. This innovation is about to transform how creators think about audio. Unveiled at the Volcano Engine Force 2026 conference, Seed Audio 1.0 merges dialogue, music, sound effects, and ambient sounds into one unified output. It's like having a full orchestra, sound designer, and dialogue engineer all in one tool. The model supports zero-shot reference, enabling seamless integration of sounds without prior examples. It can also handle multi-character dialogues, making it ideal for creating podcasts or interactive media experiences. Here's how it works. All-in-one text-to-audio generator. This model integrates various audio layers into cohesive scenarios, allowing users to create rich, immersive soundscapes from a single input. Utilizes natural language prompts. The system converts simple text inputs into complex audio scenes effortlessly. This means even users without technical skills can produce high-quality audio content. Supports Foley effects. By layering precise sound effects, Seed Audio 1.0 can accurately replicate realistic audio events, enhancing storytelling and engagement. API integration. Available through ByteDance's Volcano Engine, this feature facilitates easy enterprise adoption, allowing businesses to seamlessly incorporate it into their own workflows. Despite its potential, there are notable uncertainties. The absence of detailed performance metrics leaves questions about how Seed Audio 1.0 compares in audio quality to existing tools. Furthermore, its adoption rate among creators is yet to be established. As it stands, it might face challenges regarding ByteDance's long-term integration strategies and the potential dependency on the performance of underlying models for accuracy. For those interested in exploring this technology, visiting seedaudio.run, https://seedaudio.run/usource-openai, provides access to the API documentation, where one can experiment with generating audio scenes using natural language prompts. This offers a practical avenue to test its capabilities and explore its potential applications. In summary, Seed Audio 1.0 isn't just a tool. It's an entire audio solution poised to redefine production standards across industries. By simplifying and streamlining the audio creation process, it lowers entry barriers, enabling a broader range of creators to produce professional-grade audio content effortlessly. Consequently, it could profoundly impact fields such as game development, interactive media, and AI storytelling, offering richer and more engaging auditory experiences. Enter the world of RBox 35B JGOS, brought to you by VKUE, a model that's changing the game for AI deployment. Traditionally, powerful AI models required equally formidable hardware setups. RBox challenges this norm by performing efficiently on minimal hardware. Packed with 34.7 billion parameters, this innovative model breaks free from the shackles of high-end computing, democratizing AI access for smaller businesses. By sidestepping the need for expensive GPUs, it paves the way for widespread adoption in sectors like healthcare, finance, and real-time analytics. The model's architecture is carefully designed to minimize overhead, allowing efficient processing even in resource-constrained environments. Here's a closer look at its capabilities. Optimized for low-resource operations. By reducing computing overhead, RBox 35B enables efficient processing, which translates to lower operational costs and higher accessibility for businesses wary of investing in high-performance hardware. Deployable on consumer-grade hardware. Unlike traditional models requiring hefty GPUs, RBox can thrive on consumer hardware setups. This accessibility allows small and medium-sized enterprises, SMEs, to integrate AI solutions without costly infrastructure upgrades. Seamless ecosystem integration. The model integrates with existing software ecosystems, reducing the friction often encountered during AI adoption. It allows companies to take advantage of advanced AI technologies without overhauling their current setups. Rapid integration. RBox 35B's design facilitates a quick integration process, enabling businesses to embed AI into their workflows without significant delays or the need for extensive infrastructure development. While precise latency or cost benchmarks were not disclosed, the expectations are that it rivals traditional high-performance models. The ability of RBox 35B to handle real-time applications on minimal setups is a major selling point, promising performance that doesn't compromise despite reduced hardware dependency. However, certain trade-offs exist. Deploying complex tasks on lower-end hardware could introduce variability in performance. Under substantial load, performance degradation is possible. The long-term impacts on stability when running continuous heavy processes on minimal hardware remain an area for further research and development. For those looking to leverage this technology, exploring deployment strategies on consumer hardware is recommended. Reviewing comprehensive documentation on setup and integration processes can provide valuable insights. Additionally, benchmark the model's performance against existing AI frameworks to fully understand its capabilities and limitations within your organizational context. The big takeaway? RBox 35B is breaking down entry barriers, making high-caliber AI capabilities a reality for more industries than ever before. It challenges the conventional need for substantial infrastructure investment, enabling broader adoption and potentially transforming how different sectors approach AI deployment and utilization. Mira Murati's Thinking Machines Lab is forging new pathways in AI customization with their innovative Tinker API. In a tech landscape often dominated by generic models, Tinker introduces a tailored approach by allowing users to adjust AI model weights according to individual needs. This evolution could significantly impact how AI is utilized across various industries, offering unprecedented flexibility and personalization. The premise behind Tinker is straightforward yet ambitious. Enable users to fine-tune open-source AI models using their unique datasets. This customization process is facilitated by methods like low-rank adaptation, LoRa, a technique that streamlines fine-tuning by adjusting model weights without necessitating a complete retraining. LoRa accomplishes this by focusing on low-dimensional subspaces within the model's parameter space, thereby making the adaptation process both efficient and accessible. Key features and technical insights. Tinker API functionality provides an interface for users to customize AI model weights, aligning them closely with specific operational requirements. Low-rank adaptation, LoRa. LoRa simplifies the customization process by allowing adjustments to be made efficiently, sidestepping the complexity of full-scale retraining. This technique is particularly advantageous as it reduces computational costs and time, making AI customization feasible even for smaller developers with limited resources. Dataset integration supports integration with diverse datasets, enabling models to be trained in a manner that truly reflects their intended application. This alignment enhances AI solutions' accuracy and relevance in real-world settings. Universal accessibility. The API has been designed for ease of use, catering to both large enterprises and indie developers. By lowering barriers to AI customization, Tinker democratizes access to advanced AI tools, inspiring broader innovation across sectors. Despite its promising capabilities, Tinker does face some challenges. The effectiveness of model customization is still largely untested in large-scale settings, raising questions about its scalability. Additionally, custom model fine-tuning demands a certain level of technical expertise, which might limit its immediate appeal to smaller, less technical teams. Another potential issue is the risk of overfitting, where a model becomes too tailored to a specific dataset, performing poorly on new data. This highlights the critical balance that developers must maintain between customization and generalization. For those eager to explore Tinker's potential, the Thinking Machines Lab website provides comprehensive API documentation, including sample code snippets for practical demonstrations. Users are encouraged to engage with community forums, sharing use cases and insights to further refine the tool's application. In a world shifting towards user-driven, dynamic AI models, Tinker stands out as a pivotal development. It not only offers a tailored approach to model customization, but also signals a broader transformation in AI application, a move towards more personalized, effective, and adaptable solutions that align closely with real-world demands. Whether this approach will set a new standard and inspire similar methodologies in other labs remains to be seen, but Tinker's potential to revolutionize AI usage is undeniable. In the ever-evolving field of AI, distillation techniques play a crucial role in enhancing model efficiency, with recent advancements primarily focusing on on-policy self-distillation methods. These methods are gaining prominence for their potential to refine large language models, LLMs, by utilizing internal outputs to increase efficiency without substantially increasing computational costs. Traditionally, knowledge distillation involves a larger model, known as the teacher, guiding a smaller model, the student, to emulate its performance. However, on-policy self-distillation flips this script, allowing a model to learn from its previous outputs, effectively using itself as the teacher. This method is exemplified by the Gemma 4 model, released in April 2026, which uses innovative architectural and distillation techniques to accomplish comparable or superior performance with fewer parameters. Key innovations in Gemma 4: on-policy frameworks. These encourage models to utilize outputs from prior states as feedback for learning, promoting adaptability and improved self-assessment. Diffusion language models, DLLMs. These models integrate self-teaching mechanisms, allowing them to adjust their predictions based on past performance, thus enhancing supervision and reducing dependency on static datasets. Multi-query and sliding window attention. These methods optimize memory use, improve processing efficiency, and contribute to a dense intelligence output. Self-distilled reasoner. This mechanism supports continuous learning by enabling a model to refine its reasoning based on its evolving internal evaluations. Stabilizing techniques. RMS norm and logit soft capping are deployed to enhance numerical stability, ensuring that the model remains robust even as it undergoes self-driven learning adjustments. Benchmarks and achievements. Gemma 4 and similar models have shown that on-policy self-distillation can significantly reduce the computational resources needed during both training and inference. This efficiency could translate into a 20 to 30% reduction in energy consumption, which is a vital consideration for scalability in AI deployments. Additionally, the application of techniques like RMS norm leads to noticeable improvements in accuracy and stability, making these models not only efficient but also reliable. Challenges and trade-offs. Despite its benefits, on-policy self-distillation faces challenges, particularly in maintaining model stability during continual learning phases. There is the risk of catastrophic forgetting, where a model might lose previously learned information when exposed to new data. Furthermore, models might struggle with out-of-distribution data, failing to generalize beyond the contexts they were primarily trained on. Research continues to explore these challenges, aiming to balance specialization and generalization without sacrificing performance. To effectively explore these advanced techniques, researchers and developers are encouraged to delve into recent scholarly papers detailing self-distillation methodologies. Implementing these frameworks might offer practical insights into improving application performance, particularly for personalized AI systems that benefit from continual adaptation. In conclusion, advancements in distillation techniques like on-policy self-distillation promise to reduce training costs and broaden AI accessibility. However, adopting these innovations requires careful strategy to mitigate potential pitfalls, such as overfitting and instability, ensuring these powerful tools are deployed effectively across varied applications. That's a wrap for today's Daily AI Brief. We've explored groundbreaking tools that are pushing the boundaries of audio production, AI accessibility, model customization, and efficiency through distillation. Embrace these innovations and see how they can impact your work. Until next time, keep experimenting and stay curious.